I'm Myrna Siegel. I'm Program Chair of the League of Women Voters of Anne Arundel County. The subject of tonight's program, projections for rising sea levels, is particularly relevant to Anne Arundel County with our 500 miles of shoreline. A recent study by NOAA indicated that as coastal sea levels rise, there's an increase in nuisance flooding. And Annapolis was at the top of the list of areas with an increase in such flooding. In fact, the news release of the study was accompanied by a picture of flooding in downtown Annapolis. Our speaker tonight is an expert in the area of oceanography. Dr. Donald Boesch is a professor of marine science, president of the University of Maryland Center for Environmental Science, and University System of Maryland's Vice Chancellor for Environmental Sustainability. He earned his BS in biology at Tulane University and PhD in oceanography at the College of William and Mary. Dr. Boesch has conducted ecological and oceanographic research on coastal and continental shelf ecosystems along the Atlantic coast, the Gulf of Mexico, Eastern Australia, and the East China Sea. He is a past chairman of the Ocean Studies Board of the National Research Council and was appointed by President Obama to the National Commission on the Deepwater Oil Spill and the offshore drilling. Dr. Boesch has 40 years of experience in the application of science in ecosystem restoration, including in the Chesapeake Bay, the Florida Everglades, and coastal Louisiana. I give you Dr. Donald Boesch.
Thank you. That was a very generous introduction. I was a little 40 years thing bothered me. The one thing she left out, though, is that I'm your neighbor. I'm a resident of the Annapolis area. Very, very proud to be. Wonderful place to live, as you know. What I'd like to do today is to get you a little deep insight into something you've heard about. This is sea level rise. It's one of the manifestations of our changing Earth. We'll talk a little bit about why it's changing and how it affects sea level rise. But I'm gonna throw some science at you. Some pretty interesting, cutting edge, multidisciplinary science. Having said that, I gave almost the same talk to a group this summer of middle school students, and they got it. They got it fully. Now, they were gifted and talented, so. but at any point in time that you don't understand what I'm trying to explain to you, just raise your hand, stop, I'll explain it. Because that's what I really, my objective here is to help you understand how science helps us understand how the world in which we live and how it's changing. The story that I'm going to tell is a responsibility I had being assigned by Governor O'Malley to develop new projections for Maryland sea level rise. And as you'll see, it's not as simple as it sounds. And I assembled a group of experts from the region, the broader region, not only Maryland, but the surrounding states. In fact, one of those experts turns out to be a bright man, a young professor at Rutgers, who's actually been a real star in this area recently, is a gentleman named Bob Kopp. The last name sounds familiar. He's the son of our state treasurer, Nancy Kopp. So he was one of the scientists who helped us in doing this. So let me kind of walk you through how we got here to this, these new projections and how we did them and what they might mean for us in the region and in Annapolis particularly. So in 2008, shortly after Governor O'Malley was elected, the General Assembly, Dick is here, he tells you the dynamics of the General Assembly. The General Assembly was waking up to this issue of climate change, and they didn't know quite what to do. There was an effort to try to pass some legislation which would put Maryland out in front of dealing with the challenge of climate change by reducing our emissions. It failed. This was the governor's first term as governor. So he came out of that and he says, look, this is a real issue. I've got to do something about it. We've got to have an informed approach to this. So maybe next year we can come back and look at this issue again. So he established a climate change commission under executive order, since you can only control what's the executive branch, there are mostly people, agency heads, mostly, and some members of the General Assembly. And they set about trying to decide what we needed to do here in Maryland. And what we need to do is multifaceted. It involves how do we prepare ourselves for the changing climate so that we can minimize the undesirable negative impacts, and also what can we do in our part to stop the climate from changing, or at least slow it down, at least limit the amount of climate change. These two things, the terms kind of confuse people, but are called adaptation, that is, climate's going to change and how do we adapt to it, and mitigation, how do we mitigate or stop or slow the rate of climate change. So what the Commission did was produced a variety of reports, and I was tasked with leading one of them that had the basic challenge of taking the best knowledge that we had. We used, in this case, state experts throughout our universities and some other folks, some of the federal agencies and so on, to kind of develop a plausible scenario based upon the science that was available at the time of what climate change might mean for Maryland. So we produced this booklet called Global Warming in the Free State. And that actually was very important because it then served as a basis of saying, for the Commission and the General Assembly, you know, we've got, this is not just about polar bears, this is about us, where we live, and so we need to begin to take action. So I'm very proud of this work, but it was looking at all aspects of climate change, how it affects our health, heat stress, agriculture, water supply, anything you can think of to try to address. And so one of the small parts of that is the sea level rise issue. Now, sea level rise is obviously interesting, important here in Maryland because we have a lot of coast and we have a lot of low-lying areas in our coast. So this was a prominent feature. But we only did one part of this, and we made some projections of sea level rise, what sea level rise might be in 2050 and 2100. And we used a variety of assumptions in those projections, but they were on-the-fly, quick projections based upon available literature. First of all, let me tell you, if you don't think sea level is rising, all you need to do is look at the tide gauge data. We have in Baltimore, we have one of the longest tide gauge data sets in America. So it goes back into the 19th century, actually. And so that tide gauge is actually founded on a piling which is on bedrock. Okay, so we're not adjusting it. This is real change of the relative level of the water in Baltimore Harbor compared to that standard. And you can see here, over the 20th century, we had about 1 foot of relative sea level rise. That's relative the land to the water. And this idea of relative sea level rise is important because, as we'll see, what we see as relative sea level rise is in part because we're sinking a little bit, in part because the ocean is rising. So we have to bring those two into play. So fast forward, we did some marvelous things in just a year or two in Maryland. I don't know if this is kind of an untold story, but we produced this report, the Climate Change Commission. We actually our General Assembly passed a law that says it's our state policy to reduce our emissions by 25% by 2020. Pretty ambitious goal at the time. And setting about ways to do that under the rationale that we need to be part of the solution. We need to adapt to climate change, but we also need to be showing that we're going to help lead the effort to try to address the problem. Other legislation that was passed dealing with clean electrical power. We've since had more efforts on renewable energy. A whole variety of things happened, and including some legislation just passed this last session that had to do with Maryland state policy that recognizes that sea levels are going to rise, and that for the state government at least, we should be prudent and we should not make stupid decisions and build things in places that are going to be put at risk. So it basically says that when the state makes investments, whether they be state buildings with roads, so on, we have to take this into account. So the question was, even before that bill was passed, to us, okay, scientists, you gave us these estimates on the fly in 2008. There's been a lot more research that's been done, a lot more controversies about sea level rise. What's the latest best science that we need to do? Let's update those projections. And so this is what we did. I should also point out, you know, we had 2 years ago, we had the President's Climate Action Plan. And part of that, you see the manifestation now and the whole debate about power plants and regulating CO2 emissions from power plants. All this is going on. So this is what we did. We brought a group of experts together. We worked through the problem. We did this right here in Annapolis, right on Park Place, West Street, just down the street here. We put these experts together and worked through this issue and problem. Backing up a little bit, I showed you the 20th century, right, for Baltimore. So what's been sea level been doing over the longer term? Now, we know, maybe you don't know, that sea level is risen dramatically and fallen dramatically over time. Did you know, like 12,000 years ago, do you know where Ocean City was?
It wasn't there.
It wasn't there, you're right. But if there would have been an Ocean City, where would you have to go down the ocean?
Underwater?
70 miles farther offshore. Right? The Chesapeake Bay was a river valley.
Right.
So we had much lower levels of sea level. Why is that so? It was an ice age. So we had a lot of water sitting up on land and ice. Massive amounts. And of course, when the ice then melted, filled up the ocean, so that's what caused that sea level. And those cycles have been going on for some time. Those cycles are 1,000-year, roughly 1,000-year cycle. 100,000-year cycle. 100,000. So more recently, in the time in which we are doing things, we've settled here, not only here, but our European civilization has developed and so on. One of the interesting things about this is that sea level has been unusually stable. How do we know that? We didn't have time. We didn't kind of do archaeology on old tide gauges, you know, because they didn't have any. Scientists are clever, right? You know that. So these scientists have put together this information, and they've actually gone and done this from putting cores in salt marshes. Now, why salt marshes? Salt marshes, you know, intertidal washes out along the bay. As sea level rises, if it rises slowly enough, they can actually build soil. And the plants, all of the debris from the plants and the sediments that are trapped can actually build up. So actually, by dating the rate at which that soil is accumulated, you can understand sea level rise. And how do you know where the sea level is? They use microfossils of little animals, protozoans, that live only in the intertidal zone. So by tracking where they are and then dating, using radiocarbon and other dating techniques, we can understand the time sequence of sea level rise. This is what this curve is. It's called, wonderful name, reconstruction, paleo reconstruction. So what it shows is that over the last 2,000 years, sea level has been pretty flat until the 20th century. This is the range of estimates. We've had these episodes where we've had sea level rising at a rate of about 0.6 of a millimeter, kind of stable, maybe falling a little bit. But in the 20th century, we were rising at 2.1 millimeters. It's not much, right? But it adds up, as they say. So this is the tide gauge data from average from throughout the world that I mentioned. So what we're seeing here is the hand of man taking this natural process, and what we're doing here, affecting. There's a whole field of science that ties this to warming of the earth, CO2 emissions, that sort of thing. So this is pretty undeniably a human influence. You've heard of the controversies about hockey sticks. Now, this is one of the many hockey sticks that shows the human influence of causing things to dramatically change. Now, even more troubling is that, first of all, when you have tide gauges, you know, tides, man, you know, water levels are messy. You got winds, all these other things that affect it. Plus some land is sinking, some is rising. So how do you sort all this out? Well, we got even more clever. And we now measure sea level all around the world from space. How do you do that? Anybody have a clue? Satellites. But what do they measure? Distance, exactly. So very precisely, you can measure the distance from that satellite to the surface of the Earth with the accuracy of a few millimeters. Think of that. So these satellites are going all around the Earth, measuring this all the time over all the world's oceans, not only on coastal areas, but in the open ocean. So this is what these data represent. This is the global mean sea level. The average over all the ocean, all the Earth's ocean is measured from satellites. Rates 3.2. Remember I said 20th century 2.1? So here we have this acceleration that's taking place. Problem is we only have this since 1993. So we can only interpret it at this point. It's fascinating data. Because one of the things it tells you, there are these people in our society who deny that climate's changing, the Earth is warming. And one of the things they pointed to for a while was the fact, we got here, and all of a sudden, global mean sea levels start to decline, kind of leveled off. It's over. You know what that is? That's caused by Australia. Believe it or not. Because what happened, Australia is a big dry continent, and it's got a lot of internal basins where the water, there's not no water there usually anyway. The water there is drains inland, like Great Salt Lake, rather than out. And unusually during that period, they had a lot of rainfall. So that water was coming out of the ocean and being stored on land in Australia. But once that happened, the change, we're back in this rapid acceleration.
How do we know that?
We know that because, first of all, we have this. So the curious mind, the scientific mind says, why is that so? And you look at all kinds of explanations. You look at the rate of warming of the ocean, that doesn't explain it. You look at others, and people do what's called a water budget, which they know rainfall, where it's coming down around the world. They know stream flow, river flow to the oceans.
Australia.
So that's That's not only Australia, but that's the main component of that. So if we have to then say, here we are in Maryland, Dr. Boesch, how do you give us some projections that are Maryland specific? Enough of this global stuff, right? I want to know what happens in our backyard. So what do I have to do that, to make that projection in the future? First, there are a number of factors that cause sea level rise relative to where you are along the shore. The first and foremost is the warming of the ocean. So that as water warms, its volume expands. Same mass, but it expands in volume. So this increase of the ocean volume with the same amount of water in the ocean causes the sea to rise as the ocean warms. The other big factor is that just like the glaciers, there's a lot of ice sitting on land. I'm not talking about the ice that's floating on the Arctic Ocean, because if that melts, it's already in the ocean, it doesn't affect the sea level. But the ice that's sitting on Greenland, sitting on Antarctica, sitting in glaciers. So we have to account for what's going to happen to that ice, because that can increase the mass of water in the ocean. Okay. Turns out also that the sea is not level, sea level, right? And that the level of the ocean is not just flat, because it's influenced by currents. Currents will move water on one side of the ocean basin as opposed to the other. It's influenced also by, as you will see a little bit, gravitational forces, land masses that pull the water, the force of gravity. People think gravity is only vertical, right? but it's attraction between two masses. And so it's the same attraction that pulls the tides, pulls the water to the moon from the tides. It's a gravitational force. It gives you an idea of how it can pull water. We also have to figure out, we talked about Australia, but we're also doing things that affect how much water's on the land as opposed to the ocean. We did a lot, for example, to build water storage devices, dams, reservoirs. So when we build those, we're allowing more water to stay on land than in the ocean. So that actually had the effect of slowing down the rate of global sea level rise because we were storing more water on the land. The other problem we have, now that's become more dominant because we're not building too many new dams, is water abstraction from groundwater, taking groundwater out. Water you and I drink comes from groundwater. Goes, where does it go? I know, in the toilet, right? Well, where does it go from there? It goes out to the bay, it goes to the ocean. All right, so we also have to figure out this land motion, okay? And that can be due to a lot of effects that I'll talk about, one that affects us. But it can be due to things like subsidence in delta systems because of all the sediment that comes down and piles on land. It can be due to water abstraction. It could be oil and gas production that causes the land to kind of shrink. The big one in our case is, again, this long-term effect of how glaciers affected the Earth's crust. And we'll talk about that in a little bit. So here you have to figure all these things in. So, first of all, I told you the biggest factor has been the amount of heat in the ocean. So, more heat in the ocean, same mass, bigger volume, right? So here is a marvelous data set that shows you the heat content of the world's oceans. And this is measured, it's in joules, which think of calories, okay? So think of a heat measurement, an energy measurement. So you can see that since we've really started to zoom up in this period, and one of the things you might be hearing about is this slowdown of global warming, and that's largely because the air temperatures are still increasing, but not increasing as rapidly as they have been. And what's happening, though, is that the heat's going into the ocean, and deeper into the ocean. So this is an indication. So by first physical principles, we've got more heat in the ocean, mass is constant, volume increases. Okay, so that component's now generally pretty well known. The other thing I told you is the melting of ice that's on land. Marvelous technology and science working together. Satellites. This depicts the mass of ice, changes in the mass of ice on Greenland and on Antarctica. As you can see, that mass has been declining, and it's been declining at a greater and greater rate. So in other words, rather than a straight line, it's a line that dips down. How do we know that? Satellites. So we have a satellite. How in the world can a satellite tell us how much ice is on Greenland? Well, actually, one can't. We fly two satellites, like these, and they fly around the Earth, and they are flying in tandem and have a certain distance they maintain between themselves in orbit. As they change, as the gravitational pull of the Earth underneath those satellites changes, those satellites, the pull between those satellites is affected. So by measuring that, these satellites can measure the gravitational field under the path of the satellites. So if you have something like Greenland, we have this huge mass of ice sitting on top of it, you're going to fly over Greenland and you're going to have a greater gravitational pull. As that ice melts, you have less of a gravitational pull. So this is what this is gravimetric measurements. See, a little physics here. I'll get to the biology and chemistry. So we started. So okay, these are global processes, and we weren't going to redo the science. As it turns out, when we did this, there was a National Academy of Science a study that had just done an exhaustive review of the literature and made some projections for the west coast of the U.S. Interestingly, the request of that, of the National Academy, came from Arnold when he was governor of California. He said, you know, we got to be prepared for this. So he, state of California, largely paid for this study. So we took this. Marylander actually was did he chair it? He didn't chair it, but he was on the committee. So he took this, we took this, and they gave us some estimates for 2030, 2050, 2100 of the global factors, that is, ice coming from the continents and the thermal expansion. So we use this as our starting point, but it gets a little bit more complicated. I mentioned gravity, right? That works in all dimensions, not just vertically. So what happens, I mentioned Greenland is, when you fly over Greenland, there's this big gravitational pull. If Greenland gets smaller, the mass gets smaller, what happens to the water level around? If the ice melts on Greenland, what happens to the water levels around Greenland? No.
Land will rise.
Oh, no. The gravitational pull of Greenland pulling the ocean to it is relaxed. Sea level falls in Greenland. It increases in the southern hemisphere. All right, I think so. Sea level doesn't level. Water is very fluid. So this is a map these are maps to show you what the effect of Antarctica melting. You see, this blue means falling, red means increasing. Same thing for Greenland. So we have a lot more lose to where we are. If Antarctica melts, we get more of that effect than if Greenland melts, because we're closer to Greenland than to Antarctica. Now, this is the part we talk about the land movement. Now, we are slowly sinking here in Maryland. You might say, for a variety of other political reasons, but no. We're slowly sinking. And if you really are in a dark room, it helps. But if you can really be quiet for a while, you can actually feel it. No. This is a very slow rate. So why are we sinking? Don't look at this stuff. Why are we sinking?
Melting ice sheet.
The ice sheet?
Yeah.
Yeah. So why would the ice sheet's gone? Why would it cause us to sink?
Because when it was there, compressed
Right.
the land down.
So think of I'm trying to find, there aren't any really big people here, so I can't use them. But if you're a little person, well, I don't know, this generation, you all know waterbeds, right? So think if you're sitting on a waterbed, and some big guy goes on the other end of that waterbed and sits down. What happens to you? That's what happened to Maryland. There's this big bad guy, a big chunk of ice, sat over New York and up in Pennsylvania for several tens of thousands of years, pushed the earth up where we are. That person gets up. What happens to you? Okay. But we're talking about rock, not water, so it's less fluid, so the response is slow motion. Okay.
But I don't understand why New York would not be rising as well. If the ice is gone, the weight was on it, so you have the subsidence, but then you have the reverse when the
Right.
ice is removed.
New York, well, areas north of New York are actually rising. So what would happen to sea level if you were in Alaska, let's say, where they had lots of ice?
Well, it depends.
Sea level's falling in Alaska. Right, it is, because the land is rising.
Exactly.
Right, so, all right, so that thing has to be, that factor has to be brought in. Now, the other one, it becomes really tricky. This is new cutting-edge science. I mentioned, I showed you the currents can have an effect on the water levels. What's the big current right off our shore? The Gulf Stream, right? It comes up off of the Carolina Capes, heads out to sea, but it's a massive, large volume of water movement. So because of as it comes off, it kind of takes a right going up towards Europe, it has the effect of pulling water with it. So the water on the continental shelf off of the Delmarva, say, for example, the Mid-Atlantic, is being pulled off by that big current. So if that current slows down, that pull is less, and so that causes sea level to rise along our coast. Slowing down of the Gulf Stream causes our sea level to rise. And this graph shows this in the record. These are statistically massaged, but here shows you from 94 to the present. And so you'll see that one of these lines is Annapolis tide gauge. And you can see it has these variations in it that can't be explained by other factors. Those are kind of filtered out, that actually are remarkably coincident related to the velocity of the Gulf Stream. We measure the velocity of the Gulf Stream through a variety of ways, but principally we measure it because we can know the slope, the water level south of Cape Hatteras and the water level here. That's related to the velocity of the flow.
Why is the Gulf Stream slowing?
So what we see, so we'll get to that. So what we see is this kind of variation. All of a sudden, I don't know where it is now, but we've had this period of unusual continued slowing down of the Gulf Stream that's associated with a period of more accelerated sea level rise along our coast. Why is it slowing? There was a movie, I forget the name of it, a few years ago that had to do with apocalyptic view of climate change. That the scenario was climate change happened and New York City froze. Remember that movie?
Yes.
So the reason is the Gulf Stream. What drives the Gulf Stream is this big conveyor belt of flow of the world's ocean. It's a little bit related to the turning of the earth, that kinds of, but it's mostly related to the fact that the water goes up to the north, south of Greenland and Iceland area, and it warm water, Gulf Stream's warm. It gets up there, what happens to it? Cools. Cool water sinks. So it's a conveyor belt driving. So the belt is driven by the cooling of water in the North Atlantic. So if the North Atlantic gets warmer, the force that's driving that conveyor belt is diminished. So one of the concerns is that global warming might actually mean cold, very cold conditions, not in New York, but in Europe. So if you take Europe, you've been to, say, in France, the latitude of France is like somewhere in Nova Scotia or something. It's really high up there, but it's got a mild climate, and that's because the Gulf Stream is warming it. So if that diminishes, then they might have actually cooler conditions, Northern Europe. So that has to be factored. So putting all these together, I don't expect you to read all this, but we've got the thermal expansion component. We have a range of estimates, and our best estimate for 2050 and 2100. Glaciers, Greenland, Antarctica. You see we've used a different fudge factor for the two, because here Antarctica matters a lot. Greenland, not so much. The dynamic, this is the ocean current effect, and the vertical land motion, which is the sinking of our region, to come up with what we project as relative sea level rise for Maryland. So what we're saying here, by 2050, our best estimate is 1.4 feet. Mind you, the whole century last century was less than 1 foot, slightly less than 1 foot. But it really gets interesting toward the end of the century, the next 50 years, because then the best estimate is 3.7 feet, almost 4 feet, of sea level rise. And the range of possibilities really gets, because there's a lot of uncertainty. So it could be 6 feet. So if you were going to plan for something that's going to be around, we expect to be around and so on in this period, we better well plan probably for the outside, the 2 feet sea level rise. Here, we might have a little more time to figure it out. But if we're planning things that we expect to be around in 100 years and are very sensitive to this, like a hospital, be mindful of that, because that's going to affect the risk that you have as a result of rising seas. Fast forward. Since then, early this year, the Intergovernmental Panel on Climate Change produced its 5th global assessment. I won't go into all of it. And they presented even clearer evidence about the warming of the Earth. This is from 1850 to the present. These are global mean averages for land and surface ocean temperatures. And you can see, decade after decade, it's been going up of late. We've got about 1.6 degrees Fahrenheit and increase in global mean temperature. Slightly more, by the way, in this region.
We
But
already have that?
yes. And that's actually true in the land temperature. It's actually true in the bay, too. Because we see the same kind of increase in average bay temperatures that we're seeing. We have our lab in Solomons that's actually been measuring water temperature data the year since the 1930. Shows that clear signal. But going forward, then it really takes some science and models, complex models and projections. But to simplify the case, the IPCC took 2 scenarios. One is if we just kind of continued as we were. Our emissions would continue to grow as the world economy grows and the people grow through the rest of this century. This is this 8.5 scenario, business as usual, we'll call it. The other, they said, they backed up. They said, if we're going to keep global mean temperature, increase in global mean temperature below 2 degrees C, what do we need to do? And the 2 degrees temperature was taken by general international consensus because that puts us in more dangerous territory. And so this scenario, and we can see we can actually then level it off. And you can see it keeps below 2 degrees C. Assumes, yeah.
Was the 1.6 Celsius or Fahrenheit from the previous?
The last one I told you was Fahrenheit. I had Celsius as well.
Okay.
So this scenario involves slamming on the brakes. It involves reducing our emissions very dramatically, maybe 60, 70% by 2050. And by the end of the century, we will have actually a net, we have to be taking CO2 out of the atmosphere. No net emissions or better. So it's a pretty pretty ambitious goal in order to stabilize the climate, the warming of the Earth. Not on what we have now, but at some higher level that stays below the safety zone. So that's why there's a sense of urgency. So this takes into account moving forward. What does this mean for sea level rise? This is another study which shows it's slightly different, but the same 2 scenarios, business as usual, and then there's a rapid reductions. And we can see, as opposed to temperature where it levels off, sea level keeps going. Different rates, we have much higher sea level here than we would here. But what this means is that once we start melting things, it's hard to stop them. So what we are now, so this way, I'm sure, I imagine 80% or more of the people in here, like me, have grandkids, right? It means that this is not a problem I can turn over to my grandkids and their kids. Because unless we do this in the next 20, 30, 40 years, there's nothing they can do about it. They can't slow sea level rise. This is the 21st century challenge that has multi-century implications.
These reductions are, you're assuming that they're worldwide or they're local?
They have to be worldwide.
They're worldwide. That, of course, is wrong, yeah.
Right. So then the obvious question is, what can little old Maryland do about it? Well, little old Maryland happens to be the richest, most educated state in the richest, most educated country in the world. And why would we think that anyone else would do anything about it if we do? That's my sort of simple answer to that question. Just to show you, I mentioned Bob Kopp, Nancy Kopp's son. She was involved in doing analysis after ours that remarkably came out bang on. The rates using the same similar factors, even more updated data on warming. So now we think we're pretty confident that these projections for 2050 and 2100 you can rely on them. So what does this mean to Maryland, our state? This is a map that shows you the elevations of low-lying land. So that the areas in orange and yellow, or I'm sorry, the areas in light blue, I should take it. These are areas like Blackwater, Smith Island, they're marsh, basically. They're at just slightly above, sea level or slightly above. The greens are between less than 2 meters, less than 6 feet above sea level, and the orange yellows are 2 to 4 meters. So the way you look at this, or interpret this, is that the areas, the blue areas, the marshes, are going to be very hard to maintain. And then they might migrate onto the areas that are now fastland, but we got a challenge with that. And the green areas are the areas that in the 20th century are at risk of inundation on a daily basis. The orange and red areas, orange and yellow areas, are the areas that will now see new threats of storm surge. Because you remember Isabel, right? We had 8 to 9 feet of storm surge. So you got to add like 3 meters on that for storm surge. So think of sea level, not at just where that water level is, whether my boat dock is flooded that day, but think of it, that's increasing the base for storm surge. And the other thing it does is that as all other things being equal, if the amount of water coming into the bay, fresh water, doesn't increase dramatically, or the bay doesn't fill up dramatically with sediment, the volume of the bay is going to increase, which means that our bay is an estuary, between fresh water and salt. It means we're going to have saltier conditions. We already are seeing saltier conditions. The salinity moves up the bay because it's more ocean and less river. That has a lot of biological implications, things like life cycle of blue crabs, fish, and so on. So, bringing it closer to home, introduction mentioned this study. Here's the picture of them that they prominently played on the future of it in Annapolis. You know, all seen this site. You've probably seen it flooded like that, right? City dock. So the point of the study was that to say not just these apocalyptic scenarios, but how do we see the effects of this on a regular yearly basis? And what they've taken is sites along the East Coast and Gulf Coast, and they've established what this area calls nuisance flooding, so that if it's over a certain amount, how many days do you get over that amount? In Annapolis, that nuisance flooding level is 1 foot over the higher high water. So higher high water means that you have a tide annually, so it's the higher normal tide that you see during the month. So this is 1 foot over that. And in 1957 and 1963, the frequency is 3.8 times a year. I'm sorry, this is 2007 and 2013. I made a mistake there. It's 39 days a year. So this is the face of sea level rise. It's a gradual thing. It kind of escapes your notice. And that so many people live around the bay and properties. I lived on the bay for 20 years. Sea level has always been there. It's never moved. But it kind of creeps up on you, right? This is a clear sign of it. So, as I said, what the state's doing about it is that we now have an executive order that's now been codified in the law that says we're going to be smart about this in our coastal areas. That's going to affect the siting and design of our infrastructure, and it's now codified in the law. And the logic behind this is that if the state doesn't do it, how can we expect local governments, how can we expect the private sector to take these precautions? And so this is not only state policy, but we're trying to have outreach to the private sector and local governments. And it's doing that, it's producing lots of tools. I have to say, Annapolis is kind of on the forefront of using this in their thinking and design to help local governments plan for this future. Let me just finally close with this last slide to say I really appreciate the opportunity to talk with you. I'm fundamentally, at my core, my heart, an educator. I spent my whole career working in universities. And what I came out from all the work I've done on the scientific side about climate change and thinking that it's a multi-generational problem. So we need to teach our younger people about, better understand where the world works, because in their daily lives, but in doing so, to help them understand the risks that we have to deal with and the challenges, the choices we have to make. So we have a large project that's been funded by the National Science Foundation that I lead. It's called Made Clear, stands for Maryland. This is a venture with Delaware. Climate Change, Education, Assessment, and Research. And our audacious goal is to make sure that every student in our 2 states, through their training in schools, gets exposed to the scientific principles that underpin this idea of what's causing climate change. And to do that in a way that it's not a separate curriculum, but it is part of their science education as they deal with the new emerging next generation scientific approaches that we're putting into the schools. So anybody with some ideas or thoughts about that, I'm pleased to see as well. This is a wonderful class. You've been attentive and asked great questions, so thanks. Thank you. Yes, ma'am.
Well, these emissions, you say that in the 20th century we must reduce the emissions.
21st century.
21st century. What are we doing? What's the possibility?
Okay. Well, first of all, there's this. Someone pointed out, it only works if we do it around the world. So how in the world we do that? Because we have the United States is. Let's put this bluntly, we're responsible for most of it. This to this point. So most of the CO2 in the atmosphere, the anthropogenic, the additional CO2 was added. It's got made in the USA. So if we then go to a third world country, or a place like China, that's now passed us by in terms of their emissions, you ask them to reduce their emissions, they say, yeah, but, look at what you've done to us, how much CO2 you've added in the atmosphere, and our emissions, even though we've passed you in global emissions, we're still producing, our emissions are like 1/5 to 1/6 of yours on a per capita basis. So you guys have to show that you're going to really reduce your emissions before we take action. So that on a global basis, most analysts say the deal is the U.S. and China, the 2 biggest emitters. If we can come to some consensus about how we're going to do this, that doesn't advantage our people, that's the key to the global solution. Within the U.S., what do we do? Well, we had a bill that passed the House of Representatives called the Waxman-Markey bill some years ago, 6 years ago, I guess it is now. Didn't pass the Senate, and there's no appetite to pass. And that was a so-called cap and trade, in which there's several ways to deal with it. It all falls to the basis you need to put a price on it, let the markets work. So you can do that in various ways. You can tax it, carbon tax. A lot of people are advocating that's the most efficient way. The Washington Post, if you read the Washington Post like I do in the morning, they have editorials periodically saying, let's just go to a carbon tax. But what was done was sort of a more conservative business approach called cap and trade. Set a limit and allow for people, trade credits for emissions and things of that sort. Tried to put that in place and failed. So what's now being done is the president has taken action on things he has some control over. And it's questionable. It's going to be already been challenged in the court. It's going to be challenged again in the court how much control the government has over it to deal with power plant emissions. So what we have now is rules that are going to be ratcheting down the CO2 emissions from power plants. Power plants have traditionally been regulated for things like mercury and nitrogen and sulfur, things that we know cause human health issues in the immediate area. Now they're being required to reduce CO2 emissions. What that's doing is making it almost impossible to build new power plants that burn coal, because coal produces a lot of CO2 per BTU. So that's been driving, for example, a lot of the conversion to natural gas. It's been driving the fracking issue, so that's part of the transition. So the question is whether we can transition to that less carbon-intense fuel, but then ultimately we have to move from there to renewable energy. And, so So that's the
Nuclear,
challenge.
wouldn't that happen?
Well, nuclear is certainly in Maryland. Nuclear is a big part of our electricity supply, and and there's a lot of advocates. The challenge is that there's just not many new nuclear plants being built around the world for a variety of reasons. So it's cost among them and liability.
Yeah, it's the highest cost energy
It's
source
cost,
right
right.
now, by far.
Could you comment on the move toward fracking
Mm-hmm.
and how that's gonna affect all of this, if you have a
Right.
idea?
Right. Well, everyone knows what fracking is, right? So what this has done is that it's really increased the supply, U.S. supply, because we've been the leaders in the fracking technology of natural gas, pretty phenomenal. And in a greenhouse gas or global warming perspective, as well as an energy independence perspective, it's actually had some positive benefits because we've been able to transition more to natural gas for our electricity production, less coal. Not so good if you're worried about miners in West Virginia or Western Maryland for that matter, but that's the way these transitions take place. A lot of the concerns about fracking, two concerns about fracking. One is the more immediate environmental effects, of putting all these fluids under the earth, and what do you do with the waste, and what do you do with with contamination of groundwaters, and building roads, and having truck traffic, and all those things that affects people's personal environment. Those challenges need to be met. We have two things that the university has done to help our state in that. One is my center produced a report, a year and a half ago, on best practices, so that if the state did move forward, what could we do, what could we impose on the industry to make sure that we minimize those environmental damages? And then there was one just a month or so ago by the School of Public Health at College Park that looked at the human health issues. So pay attention to those. Those are going into the commission that's advising the government on fracking. The other concern that people have, and why you see it's manifest in the opposition to the Cove Point, the export facility, is that it's just it's like methadone rather than heroin. It's just another addiction that doesn't get us off of fossil fuels that we need to do. So it basically prolongs the agony rather than actually getting us to make a more rapid transition to renewable energy. The Obama administration has supported, increased natural gas production, obviously with proper safeguards, but because they take more of the broader view about we need to move to less carbon intense fuels while we're figuring it out. But there's a whole bunch of sides to that debate.
It consumes a lot of water, too.
It does.
Do you have some projections on the changing ratio between fresh water and salt water as the glaciers melt and other things that you talked about occur?
I can't tell you overall, but one of the things that happens, we talk about global warming, but then scientists also talk about climate change, because, and then there are those who make mischief. Wow, they used to call it global warming, now they call it climate change, they're trying to change. No, they're two different things. Warming is warming. Climate change includes warming, but a lot of other things will be affected. One of them is precipitation. Now, how will precipitation be affected? First principles with respect to climate change. As the world warms, what happens to the water in the ocean? It evaporates. So we got more water coming up, but it's got to come down. So the net effect is more precipitation. But the way circulation of the earth works, it doesn't come down where it goes up. So this means that precipitation is going to increase dramatically. It has been increasing in the around equatorial regions and in the northern and southern latitudes. All right. So the mid-latitudes actually are actually getting and projected to be getting drier. So if you take the southwest of the U.S., they've got a real dire situation now. You wouldn't think of it this last week, when they had these floods and everything. I was talking about these people are never satisfied. But where Maryland is, we're kind of at the transition zone. So there's a fair amount of uncertainty about how it will affect our precipitation patterns, because it depends on how this thing plays out. But the best ideas are that our precipitation patterns have increased, particularly in the winter and spring, but have been, or are going to stay stable or decline in the summer. So what this means is that, you know, forget about your lawns, but our agriculture. Most of our agriculture in Maryland is rain-fed, so they're going to have more increasing problems. They're going to be looking for groundwater to irrigate. So those are the kinds of challenges that we have to face. The other thing about precipitation is that, based upon the basic science as well as the observations, as the planet warms, the precipitation is delivered in more extreme episodes. So the rain is heavier rainfall, but also punctuated by longer periods of dry. So you're going to have, you know, these periods during the summer where you might have, you know, 3 or 4 weeks without water, without precipitation, and all of a sudden just heavy downpours. And, you know, to a certain extent, you can't say one episode, but some of the things that we've seen are very consistent and averaged over multiple years. This is what we're seeing. Tells us that we need to be mindful as we deal with, I can't help it, as we tax the rain. as we deal with our stormwater management, you know, that we now need to do for bay reasons, we need to be mindful of these changes. Or if we're dealing with just things for drainage, for safety, you know, we need to be supersizing, if you will, because, you know, we need to prepare for that future that's different than the past.
I think that issue of variability needs to be stressed more, that through all the climate features and activities that we're going to face more and more, well, the models suggest that there will be a lot more variability, and that's a lot harder to live with than just getting colder or just
That's
getting
exactly
warmer.
right. In fact, a number of public opinion polls say that's what people resonate most. You know, if they can associate this with these extreme events, they're more motivated, they get attention. Thinking that it's going to be warmer. You know, it's hard for people to imagine what it's going to be like here. You and I are going to be around this, yeah, but you know, my grandkids, or your grandkids, you know, after the middle of the century, you know, it's going to be a rare day with temperatures less than 90, and we're going to have, you know, not just 2 or 3 days, but maybe 30, 40 days of 100-degree temperatures here. So I tell people, you know, when you try to think about this, what it means in terms of temperature. Good news is that the winters, you don't have to move to Charleston because it's going to come here. But the summers are going to be like Phoenix with humidity.